Here is a presentation for lecture 1, which talks about the meaning of research as a way of knowing. Okay, so the first slide, I'm going to explain the different ways of knowing as to set the stage. Okay, so there are 4 different kinds of knowing is recognized or categorized. Number 1 is intuition, number 2 is authority, number 3 is reasoning, and number 4 is observation. Okay, so in the next slide, I'm going to give you a little bit more detailed explanation of these 4 different ways of knowing. Okay, so the intuition is generally regarded as least trustworthy source of knowledge because you don't know why and how you know that. Like, for example, let's imagine that I intuitively know that the men are more promiscuous than women. But it's just the intuition and I don't remember where I learned that from, or did I actually observe it? Can I cite the specific observed evidence? Or is it based on some sort of reasoning? You're not sure. You just know that idea. That's an example of intuition. So there is no way to explain how you know that. That's the intuition. The second one is knowledge based on authority. Like, for example, many of the things that you know is based on reading a textbook. The content of the textbook is basically authoritative because it's recognized widely as truth in the society. Okay. Number 3 is a reasoning. Okay. In reasoning, basically you draw a new conclusion based on some different kinds of facts. So it's not the direct observation, or it's not directly based on authority, but you combine several different kinds of information to draw new conclusion. Okay, so the most kind of prototypical one is the logical reasoning. Okay, I explain different kinds of logical reasoning later. Okay. Finally, the knowledge is based on direct observation. In this case, your knowledge is based on something that you directly observe. Like, for example, you can say, today is hot. This is because the thermometer is actually showing some specific temperature. So that's because the thermometer is actually measuring the temperature and you observed it. So that's in a sense, in science, we recognize knowledge based on direct observation to be most trustworthy, especially when you have an access to the method by which the observation is obtained. Okay. And then why do we need to talk about these 4 different ways of knowing? Because in science, it's your obligation to communicate the trustworthiness of the piece of knowledge that you obtain. So in scientific communication, such as in journal article writing, you need to indicate how you know what you know. So APA style is an example of embodying this belief system. So in APA style, you need to cite the source of your knowledge. Sometimes you're simply trusting the authority. In that case, you're citing some theory. Sometimes you're reasoning. In that case, you actually explicate the exact reasoning that you used in combination with the premises that you actually relied on, such as some other people's opinion, which is authority, or some observation. And finally, in case that you cite some other person's specific research or your own research, then you're basically claiming that what you're saying is based on the direct observation. Okay, so in science, like we already talked about, ultimately your claim needs to be rested or based on some specific observable facts, even though you may actually link different kinds of observable facts to your conclusion based on reasoning or authority, it needs to be, it preferably needs to be based on or related to some specific observable fact. Now we're going to move on to some insight into reasoning, which is a logic involved in your reasoning of connecting premise to your conclusion. There are three different kinds of logic that I can recognize. And the number one is deductive logic. This is the formal logic, and it's the strongest. But it's rare in science, and it happens mostly or only in mathematics and computer sciences. So the definition of deductive logic is when the premise is true, the conclusion must be true, and it shouldn't be dependent on any other things. So for example, premise is all A is B, all B is C, then the conclusion that you can draw is all A is C. It's not dependent on what is A and what is B and what is C, okay? Because only things that you need to draw this conclusion of all A is C is these two premises, all A is B, all B is C. Okay? So this is rare, and therefore you mostly are not likely to use these forms of logical reasoning in your scientific writing, but nonetheless it's the better for you to remember that. The second one is inductive logic. So this is based on probability. Okay? So the premise is my sample indicates that men are more sexually promiscuous than women. And then your conclusion is therefore, men are in general more promiscuous than women in general. So note this. The premise is based on specific observation, based on the sample that happened in specific time and space. Conclusion is more general, and you're applying all men and women. And so in this case, there is one assumption that's not specified in here. It's assumption, okay? So that is, your sample needs to be representative of the population. That is an assumption that's embedded within your premise. So therefore, it's slightly weaker because it's than deductive logic, because you at least need one assumption. On the other hand, abductive logic, which is also known as an inference to the best explanation, is there even though you have some premise, there are unlimited number of assumptions that you're relying on. So I think it's easier for me to explain this using example. So let's say premise one is if a ship travels to the east and keeps going, it will eventually come back to the same place from the west. Premise number two, when a ship begins to appear on a distant horizon, the first part you see is the mast. So therefore, the conclusion is, therefore, the earth must be round as opposed to flat. Okay, so even though this premise seems to lead to the conclusion, the earth must be round as opposed to flat, this is in part based on some specific kind of unjustified assumptions, such as a ship travels to the east and keeps going, and east is always clear to the ship, like compass can be trusted. Okay? And then also when a ship begins to appear on the distant horizon, the first part you see is the mast. So in that case, it's also rested on the premise that your observation of the mast is accurate. So there are a number of assumptions that's not really specified. So, and in many what we call logical reasoning, even though we call it, this is an informal logic, therefore it's weakest, but nonetheless, this is the most common form of reasoning, namely informal logical reasoning that's involved in scientific thinking. So, scientific method of knowing, what differentiates scientific method of knowing is that the conclusion needs to be ultimately based on some form of observation, and that observation needs to be rule-based. So there are two things, right? So it needs to be based on factual evidence, and that factual evidence needs to be obtained when your observation follows certain kinds of specific rules that's specific, articulated, and specifically explicitly stated. Here, rule-based is very important. The reason why is rule makes your study replicable. You can follow the rule in the exact same way to reproduce the exact same situation. Also, explicit recording of rules, which is a method and materials, help others to criticize the weakness or limitation of your study. And finally, rule established prior to the data collection help you interpret the results afterward and reduce errors. Okay, so the scientific method of knowing the essence is it needs to be observation, and that observation needs to be specified with the specific rules that's recorded such that other people can test it. Okay. Finally, how we need to also ask, how is science different from pseudoscience? The difference between pseudoscience and true science is actually, despite many people sounds like it's clear cut, I don't think it is. It's not clear when one is not sufficiently knowledgeable about the topic of study. One may accidentally practicing pseudoscience even though one truly believes that it's a science. So because what is considered to be acceptable scientific method is highly specific to different kinds of discipline. And most obvious difference that separates pseudoscience and true science, therefore, is the quality of evidence. Pseudoscience uses questionable practices in collecting the data, and then so some example is like use of inappropriate statistical analysis. So, and you mistakenly use different kind of wrong, incorrect statistical analysis, or relying on biased sample, or fraud where you fabricate the data. So, in case of fraud, it's obviously pseudoscience because it's clear. But in many other cases, pseudoscientific research is actually discovered later on when the better understanding about the subject matter develops. So it's not that clear. So that's why the class like research method is needed. So there's a lot of details. It's not that simple. So hope you learn through this semester all these details that differentiate high quality science and not so high quality science, namely pseudoscience. Thank you.